it is a linked answer question. It consists two questions. So the given statement for linked answer is a vapor compression refrigerating system works between the pressure limits of 60 bar and 25 bar. The working fluid is just dry at the end of compression and there is no undercooling of liquid before the expansion valve. Here the properties of the working fluid are as follows. Here in the given table the properties of working fluid are there. And coming to the question, the first question is find the capacities of refrigerator per kg of working fluid. And second question is find the COP of the cycle. So coming to the solution, so first draw the TS diagram for the given VCR. So here the condition is the vapor is just dry at the end of compression. So it shows here at the end of the compression vapor is dry, that is let us say 1 to 2 and 2 is on saturated vapor line, and 2 to 3 is condensation, and 3 to 4 is expansion, and 4 to 1 is operation. So here this is the given TS diagram for the given problem. So here 1 to 4 is at 25 bar and 2 to 3 occurs at 60 bar. So the given saturated temperature limits are 295 Kelvin and 261 Kelvin, and the given properties regarding these two conditions are S1 is equal to, first write down, let us say H3, this is on the saturated liquid line, which gives a value of at 60 bar saturated liquid enthalpy is equal to 151.96 kilojoule per kg. And also we know that S2 is equal, which is equal to 1.0332 kilojoule per kg Kelvin, which is on saturated vapor line. And coming to the remaining points, one is let us say HF1, which is equal to 56.32 kilojoule per kg, and in the same way SF1 is given by 0.226 kilojoule per kg Kelvin, and HF2 is equal, so that is equal to H3, that is already written. So here it is HF3, and let us say SF3 or let us say SF2, which is equal to 1.2464 kilojoule per kg Kelvin. And also we know that here the 3 to 4 the process is constant enthalpy process, that is H3 is equal to H4, and 1 to 2 is constant entropy process, that is S2 is equal to S1, and from this S1 we can find out the dryness fraction at the point 1, that is S1 is equal SF1 plus X into SFG at that point. Okay, already we know that SF1 and SG1 is given by SG1 is equal to 1.2464 kilojoule per kg Kelvin. Here SF3 is equal to 0.554. Sorry, it is 0.554 and it is 1.2464 kilojoule per kg Kelvin. Now SFG1 is equal SG1 minus SF1 and is equal to 1.2464 minus 0.226. So now from this equation S1 is equal to 1.0332 and is equal to SF1 is 0.226 plus X into 1.246 minus 0.226. So which gives the dryness fraction at the point 1 and is equal to 0.791. Now we know the dryness fraction at the point 1. So from the dryness fraction, from this dryness fraction we can find out the enthalpy at the point 1, that is H1 is equal HF1 plus X into HFG1. So already we know that HF1 that is equal a value of 56.32 kilojoule per kg and Hg1 is equal 322.58 kilojoule per kg. So here H1 is equal 56.32 plus and dryness fraction is 0.791 into 322.58 minus 56.32. So which gives a value of 266.93 kilojoule per kg. Now we have all the enthalpy values at all the points, that is H1 is equal to 266.93 kilojoule per kg and H2 is equal or Hg2, that is the enthalpy on the saturated vapor line at 60 bar, which is equal to 293.23 kilojoule per kg, and H3 or H4 is equal 151.96 kilojoule per kg. So now the first question is, we will have to find out the capacity of the refrigerator per kg of working fluid. The capacity of the refrigerator is nothing but the refrigerating effect of the refrigerator. So here refrigerating effect of the system comes from the process 4 to 1, that is we have the refrigerating effect or capacity of the refrigerator is equal to H1 minus H4, which is equal to H1 is 266.93 minus 151.96, which gives a value of 114.9 or nearly 115 kilojoule per kg. So this is the capacity of the refrigerator, and in the option, the correct option is C. C is the right answer for the first question. Coming to the second question, find the COP of the cycle. So COP of the cycle is equal to the ratio of refrigerating effect to work input to the compressor. Here work input to the compressor comes from the process 1 to 2. This is the isentropic process from 1 to 2, and it takes some work input of H2 minus H1. So here refrigerating effect already we know that 115, and here H2 minus H1 is equal 293.23 minus 266.93. So finally we have 4.36. So here in the second question, the right option is B. B is the right answer for the second question.